Okay, if you're tuning in, this is Mr. Brown. He is doing a midterm review for the honors and advanced honors, but right now he's only doing numbers 3 and 4 from the addendum, and these are the proofs, just in case you needed a little reminder. So here we go. Given AC is congruent to EC, so you have to mark that, and you mark that, and angle B is congruent to angle D. And that is wonderful. Now, and you have to prove, this is your final prove statement. So that's obviously going to be at the end. So we're going to take a little time, write my statements here, write my reasons here. Please be sure that your handwriting is a little bit better than mine. Number 1, AC is congruent to EC. 1 because of given. You will also see Mr. Brown divide these two steps up just because that's the way, he's been doing it for years. If you want to smush them into the first statement, that's okay, because they're both the given statements. Now, with that being said, I guess I better write that clearly in case your computer's not quite as clear as mine. G-I-V-E-N. The only way you can prove triangles congruent, really, is by all of those steps like angle, side, angle, side, angle, side, 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 angle, angle, side. Remember, you can't spell a bad word. Can't spell a bad word backwards. Can't use all A's. And then, of course, the HL. Okay, so here we go. So if you have a side right here and a side here, what would be really good if you were to detach these so you can kind of look at them individually. So you got a side and an angle, and you have a side and an angle here. If you're looking at them detached, you have a side and an angle both marked. So is there anything else that you can mark? Well, you can mark the vertical angles right here. So please, in this, do not say that angle C is congruent to angle C. There are 8 angle C's, at least 8 angle C's, and it depends on what mathematicians you talk to. There are more 8 angle C's. Were you talking about this angle C, angle 1 and angle 2? Or were you talking about angle 3 and 4? Or were you talking about that big old angle C, or this big old angle C, or starting there all the way around? Which one in the world are you talking about? So please don't put angle C, but what you can do is you can call it all 3 letters. So I'm going to call it ACB. So I can say that the measure, I don't want to call it the measure, I just want to call it the angle. Angle ACB. That is going to be congruent to, now be sure you follow order. If I go from the unknown through the one to the vertical angle, that means I have to follow the same pattern. So I'm not going to start with the D, because that's the known. The E is the unknown, and I'm going to go through the one that I know to the vertical. So that means that angle ECD, excuse me for the announcement, but number 3, this is vertical angles. Vertical. If you don't remember how to spell it, it always ends going vertical. Duh. That's the last letter. Vertical. Good. So now I've got that angle congruent to that angle. So that gave me a side, and that gave me an angle, and that gave me another angle. So I think that that's enough to prove triangles congruent. Let me make my pen stroke a little bit wider, if you will. So this would be triangle ACB B congruent to triangle ECD. Now I just screwed it all up because I wanted you to pay attention. This should be your last statement, not this. Why? They're saying the same thing, Mr. Brown. Yeah, well, so I don't care if they're saying the same thing. They got to be exactly the same. Ooh, little bitty racer, little bitty racer, little bitty racer. Okay, so what you're going to do is your last statement has to be triangle ABC congruent to triangle EDC by what way? Well, you got an angle, and you got a side. Angle, angle, side, and that side is not in between the 2 angles, so it's going to be angle, angle, side. That's number 3. Number 3. Number 3, 3, 3, 3, 3. So that's the proof. You could have gotten away with a 3-step proof. Let's go with the number 4. So it's the same diagram. So pardon me, but I've got to get all of it in here. So here we go. Number four. Number four, given AB is parallel, so none of that stays the same. AB is parallel to DE, and BC is congruent to DC. Now there's a couple of different ways you can do this problem. You can use the fact that they are vertical angles. So let's start. So I got statements here, and I got reasons over here. And number one, AB is parallel to DE. Come on, Ben, keep up. One given, and just to show you, unlike that, I would also, unlike the first problem I did, I'm going to keep them all in the same step. So that would be DC. Alright, that's a D. I promise. It's a D. Alright, so here we go. So number two. You can use the vertical angles. There's going to be two different ways to work this problem. I'll give you step. This is way number one. Good grief. Way number one. I'll give you way number two in just a couple of seconds. So here we go. So with this, if you use vertical angles, again, angle ACB is congruent to angle ECD because of vertical angles. Vertical angles. Alright. But the only problem is, all that you have marked so far is a side, again, and you have the angle. You cannot mark another side just yet. You can't mark another side because you can't say just because they're parallel, that means you're going to be congruent. Wrong. Change pen colors. The fact that they are parallel means that angle A becomes an alternate interior angle to that. If you can't see it, here we go. Poof, and poof, and poof. I really just screwed all that up, so here we go. Oh, come on, big eraser, big eraser. I like big erasers. Alright, so here we go. So, parallel line, and parallel line, and transversal right there. So angle A congruent to angle E. So number three, angle A congruent to angle E. Why? 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 Because definition of alternate interior angles. Good. Now that gives me that angle congruent to that angle, which gives me triangles congruent. So triangle ABC congruent to triangle EDC, and that is in my little box, and that is because number 4, that is angle side. Now there could have been something else done, and so let's look at the second way. Way number 2. Way number 2. Let's go back and cut the drawing out again. So here we go. On a new, not what I wanted to do. Here we go. Place a new page. Poof, right there. And I'm going to get rid of that. Problem number 3. And here we go. Statements. I got to go fast. Reasons. I'm going to put all of that right there. And I'm going to put 1 is given. Now, number 2. And so what I have currently is if I separate those two triangles, I know that BC is congruent to DC. So I know that these are congruent, and I know that those are parallel. You can use the vertical angles. If you use the vertical angles, that means you got to call them vertical angles. So again, angle ACB, ACB, congruent to angle, what is that? ECD. ECD. Again, that's vertical angles. Now, with that being said, number 3, if you had chosen the angle B, again, you're looking for parallel lines, poof, and poof, with transversal poof. That would put that congruent to that, and that congruent to that. With your vertical angles here, that's going to give you angle B congruent to angle D, and that is because of alternate interior angles. So for the triangle ABC, it's going to be congruent to triangle EDC, but this time it is because of angle side angle and not angle side. That's how you do that. And if you want to stay on, that's about a 9-minute 45 podcast. If you want to stay on for just a second, I will show you a third way, and the third way looks like this. and you can simplify it a little bit without too much writing. Here we go. You can, in your statements and reasons, the fact that those are parallel and that this is congruent, you can go right ahead and say, since those are parallel, this and this are going to be congruent, not to each other. This is congruent to that, and this is congruent to that, which automatically gives you angle, angle, side. So you can simply say statements, reasons, 1 given, 1 given, and then number 2, you simply say angle A congruent to angle E, and angle B congruent to angle D, all because of alt, int, angles, and then you go ahead and say triangles congruent to triangle because of angle, angle, side. Those are the 2 proofs. Hope you do good on your exam.